Hi and welcome to Geeks for Geeks. Today we would be discussing yesterday's problem of the day, that is distance of the nearest cell having 1. So now without any further ado, let us get started. So I will just quickly share the screen. This is the link to today's problem. Hi Yash Dwivedi. Hi Rishit Chaudhary. Okay, so just share the screen. Hi Abhilash. Okay. So let me tell you what the problem is all about. I would assume that you have read this problem. Okay. Even if you have not read this problem, if I would explain you, that would be pretty clear. Okay. So now in this problem, you are given a matrix of size n cross m. Okay. So just let me draw it. I think I need to add to the stream. Yes, it is added. Okay. Okay, so you are given a matrix of n cross m, and it is a binary matrix. What do you mean by binary? Binary means that the elements would constitute of only 1 or 0. Okay, so either the element could be, so binary string means the same, binary array means the same, binary matrix means the same. This means that the particular element would be either 1 or a 0. Okay, fair enough. So now suppose it is told that we have here 1. So let us write the given sample test case only. Okay, so how is it all coming from? So 1 2 3 4 4 into 3. Okay, we have made the perfect one. Okay, so we have here as 0 1 1 0. This is the given matrix, and 1 1 0 0. Then we have 0 0 1 1. So we are given a matrix which would constitute of zeros and ones. Now it is told that for each of the element you need to tell that which is the nearest one. Okay, so I would just tell you by the examples. For this 0, the nearest one is one distance. This is also one distance. This is also one distance. But in which direction we can move? We can move in all the four direction. We can consider this, and this. Only four direction, but not this, this, and this. This is not allowed. Okay, this is not allowed, but left, right, up, and down is allowed. Okay, now the next thing is that suppose for this one itself, so for 0 we would try to find the given one, and that is fine, and I'm okay with that. But now suppose it is 1 itself. So if it is 1 itself, so the distance from 1 to 1 would be 0, because if source is equal to the destination, then the value would be 0. What I'm trying to say is, suppose I want to meet Siddharth Hazra. Okay, suppose I want to meet Siddharth Hazra. So if I want to meet Siddharth Hazra, then the amount of energy spent on meet going and meeting Siddharth Hazra is 0, because I am myself Siddharth Hazra. In the same manner, 1, as it is itself 1, then the amount of distance is 0 for him. And other person, other than people who are other than Siddharth Hazra, that would spend a amount of time to meet me. Okay, and that is fine. Okay, like a person who is even near to me, he would need to come in front of me, no, to meet me. So in the same manner, for this other zeros, for zeros we need to find what is 1. But if the element itself is 1, the value would be 0. So we can say that for this value is 0, for all the 1 the value is 0, and it is basically understood from this only. For this 0, the nearest distance is 1. So the nearest distance is 1. For this 0, this nearest distance is 1. Okay. So then we come to here. This is also down also 1, up also 1. So 1. For this 0, the nearest distance is again 1, then 1, and then 1. So now if you observe 1, 0, 0, 1. Okay. Yes, output 1, 0, 0, 1. 1, 0, 0, 1, the first one. Okay. Next one is 0, 0, 1, 1. 0, 0, 1, 1, and then 1, 1, 0, 0. Fair enough. That is what we were coming. So this is what you need to do. Am I clear with the problem statement? Give me a quick 1 in the chat. Give me a quick 1 if I'm clear with the problem statement. So my voice is not clear. Can I have a quick yes or no in the chat if my voice is clear or not? Okay, my voice is clear, then only you're replying. Okay, camera quality. Okay, fair enough. Okay, fair enough. So now we would quickly move forward this. Okay, thanks a lot. Okay, so now we can understand that for all so binary, so we need to handle what things. So if the given is binary, then we just need to handle zeros and ones. Now we do have a solution for one. That is that for all one, the distance would be zero. And now we need to devise a solution for zero. Okay. Now we need to think of zero. Now to think of zero, what we did manually, like whenever you are coming across problems like this, the path problems kind of thing, like what is the distance and all. So whenever you come across distance and all, whatever be it, I'm not telling that even if it is this, that I'm not telling you, but in the problems where you are asked about distance, what is the v or this or that, you should always move forward what I was doing in manual. Okay, like you should have this, like मैंने जब पेन एंड पेपर में सॉल्व किया तब मैंने कैसे किया, you should analyze that thing. Okay, so in the same manner what I said in Hindi is like you should analyze how did I do it in pen and paper, and I should do the same thing in here. Like I personally solved a hell lot of problem through this. Like I solved this problem on pen and paper, then I analyzed how I solved in pen and paper, and that led me to the solution of ad hoc problems. Okay, to be honest, till the medium level problems of geeks for geeks. Okay, so now if we just analyze for one, the value would be zero. So we got half the answer by just writing it in a pen and paper. Even if you don't know some data structures or algorithms, we are good to go with the half of the problem. Now in a binary string, we just need to handle the values of zero. Now we are only concerned about zero. So now zero, talking about zero. So how did we do it in pen and paper? What we did was we tried to move forward in all the scenarios. Okay, we tried to move in all the four direction, whichever was the minimum, we had that value. We did this or not, or we would do this or not. Even if we didn't do this here manually, we would do this thing kind of thing manually or not. Yes, we would definitely. So there comes the brute force solution. How it comes to the brute force solution? Because see, for all zeros you need to, so it might be a scenario that there is a matrix like this. Okay, so I won't be drawing the whole cubes and all. Okay, suppose there is a matrix like this, and this is the zero, sorry, this is the zero and this is the one. So for this one we need to traverse the whole matrix, we need to traverse this whole matrix. So for one element we need to traverse the whole matrix. Okay, I'm clear with that. So if for 1 0 the time complexity is n cross m, that means we need to traverse the whole matrix. Then for n cross m matrix, like n cross m zeros, at max the number of zeros can be how much? Number of zeros can be that all the values are zero, that is n cross m. Okay, so multiplying n cross m on both side, it is n cross m, it is n, it is n multiplied by m multiplied by n multiplied by m. Okay, Simple enough. This won't pass. We want a linear solution. That means the expected solution is just n cross n. So we need to think of something better that we know from this point. This was the brute force solution. If this was given in an interview, you would have taken this. Now we need to think of something better. So basically, what are we doing? We are doing something like this. That suppose this is the given zero. Okay, this is the given zero. We are moving like this. 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 Okay, so it is kind of that, it is a kind of radiation kind of thing, or we are just propagating. Okay, like we are going in all the four direction. Okay, suppose this is sitting at this point, so we would say the distance is 2. It is sitting at this point, the distance is 1. And whenever you have this kind of structure in your mind, the radiation or the propagation, people who are already attending my session from the past would know this. But even if you don't know this, whenever you come across this kind of figure in your mind, like I need to propagate and see, it is definitely BFS. Now, a bonus for you, whenever you have something like this that you need to go depth like this, then it is DFS, and this is BFS. Understood where we want to do what? Where do we need what? BFS or DFS? We know this thing. Okay, fair enough. Now we know when to learn, when to use BFS and DFS. Now we move forward to this. Okay, we need move forward to this. But BFS doesn't really solve our issue. Why? Because for a single element, like for a single element, suppose this is given. Okay, let's take a very small, and that would make the things very clear. Okay, like let us just take like this, because if I draw big, it would be more nasty. Okay, like suppose the element is lying here, that is 0, and this element is lying at 1. So even if this is the scenario, then the propagation would be like this. So basically, we are again doing the same m cross n for a single element. Then for n cross m element, it would be again the same time complexity, but we want it to be m cross n. So BFS is not helping us in that much. Okay, like we know that it is BFS kind of thing, and yes, the same time complexity can be given by BFS also, but BFS is not really solving us, helping us. But that is leading to a solution. You know what? If you observe that, what is the issue? What is causing us this issue? The issue is that from here also you need to propagate, from here also you need to propagate, from here also you need to propagate. So you need to propagate from multiple sources of the same kind. You need to propagate of multiple sources of the same kind. So whenever you have this line that multiple propagation from same kind, okay, then there is a solution to this, and this is a fact which has no intuition. If you know this thing, then only this would be an intuition. The fact is that this can be solved using multi-source BFS. Now what is multi-source BFS? If you know BFS, then this video is for you. So I would assume that you already know BFS. Now, what was the code of BFS? The code of BFS was something like this. Let me quickly type it. Then this would be clear. Okay. Let me make it a little bit big. The BFS code was something like this. Okay. BFS. Okay. BFS code was something like this, that we had a queue. Okay, we have an int of q, or to calculate the distance, we can have just a pair of int comma int. Okay, but to make things simple, we would just keep a pair, and then we say that while q is not equal to empty. Okay, while q is not equal to empty, we would take out the front of the q. The front is equal to q dot front, and then we would remove the front of the q dot pop. Okay, q dot pop. and then we would traverse the neighbors of the queue. So for auto E and G of this G is graph. Okay, basically this is nothing but graph. Okay, this is graph. Suppose I have already taken the input, so we would just traverse the graph. If NG is not visited array of NG, then what we would say, we would just q dot push the value of NG, and this is fine. And we would push here the source q dot push SOURC source, and I would just write here the graph. Okay, so graph, and that is done. Okay, fair enough. So that is how we do. Okay, we visit it also when we come here. Okay, visited of front is equals to true, visited of front is equals to true, and this can be anything. Okay, fair enough. Are you familiar with this code or not? Then if not, I would explain you the code. So quickly tell me if this part of the code is clear to you or not. Quickly tell me. Just quickly tell me if this code is clear or not. So I would quickly present a window of Sublime text. So now tell me if this part of code is clear. Like if this is not clear, I would first explain this and then I would move forward. Okay. Anyone for whom BFS is not clear. Okay. BFS should be clear. So Ganpat Parmar. Okay. Anyone else for whom it is not clear? So if BFS is not clear, so this is a question of multi-source BFS. This is the level 2 of BFS. So consider learning about BFS and then solving some problems and then coming to this point. I would say, to be honest. But if you still want, just let me know. I would still explain you that. I have no issues in doing that. Okay? Chalo. Let us move forward. Okay. So the only difference between a BFS and a multi-source BFS is nothing but if you have multiple sources, then just push all of them. Just push all the sources at this point. That is the only difference. To show you the use case of that, what we can do is we can just use a loop of sources and then we can insert it. Okay. Like just insert whatever. Suppose we have n sources. So if you have n sources, just insert them at this point. That is done. And this is multi-source BFS. So at the point where you just insert one source, push all the sources at that point. And this is multi-source BFS. Simple enough. Okay. Now let us move back to the board. Now there are some more things that I want you to know. Some more things are basically this is not a graph. Okay, this is not a graph that is given or a path that is given. Okay, like we are not given an adjacency list or adjacency matrix. Okay, we are given a matrix. Okay, that is not any of the graph representations. Okay, so basically we are given the grid. So grid problems in graph are very common, even in dynamic programming, even in graph. So in grid, you need to take care of some of the things. Oops. Okay, so just let me tell you that. Okay, so now in a graph, we need to traverse in the graph. So basically, suppose I'm at this point, then at this point, suppose this value, so let me mark the indices. This is this is 0 0, this is 0 1, this is 0 2, this is 1 0 1 1 1 2 2 0 2 2 1 2 0 2 1. Oops, I have such a bad handwriting. 1 0 1 1 1 2 2 0 2 1 2 2. Okay. Now suppose from this 0 0, I move to this side. So if you observe that x remains the same and y is affected. So x is affected. So this is x coordinate. So let me just have it like this. Okay. Mhm. This is y coordinate. Okay. So if we are moving on the right hand side, then x is affected by 0 and y by 1. If we are moving 1, then x is affected by -1, y is affected by 0. If we are moving on the left hand side, then x is there by 0 and y is affected by -1. If we are moving down, then x is affected by 1 and y remains the same. Now, if you see, we can use this array and add the corresponding values to traverse this. We can use some if statement also, but it's better that we can have an array of the size 4, two array of size 4, x and y, and then we can traverse by adding to the current index. And then there is one more thing. Like from this index, we can move to right, left, up, and down. But from this index, we can't really go on this side, we can't really go on this side because it is outside the boundary of the matrix. So how to take control of that? So to take control of that, what we need to do is we need to check if the position we are trying to visit is within the boundary or not. So we can just check if it is a valid position or not by seeing that if it is greater than equal to 0 and less than equal to n or m or not. Simple enough. Like बस देख लेंगे साइज के अंदर है कि नहीं, like नंबर स्केल के बीच में है कि नहीं, and it is simple. Okay, so now the same code of BFS would continue. The implementation would take 5 minutes or 6 minutes. So am I clear with all this? Give me a quick one. Give me a quick one if I'm clear. Could you give an intuition of how multi-source BFS reduces the time complexity? How does it reduce resultant search path? Okay, so basically this is a fact. Okay, so you don't need to build your intuition for this. This is the very first thing. Next thing, if you want the intuition, okay, but if you still want the intuition, so I would just quickly give you an idea. So it is basically like this, that suppose it is there are multiple, suppose there is one thief, okay, like there is one thief, like there are suppose three thieves, okay, like suppose there are three thieves standing next to each other. One thief would go and rob all the houses and then come back. Next thief would go and rob all the houses and come back. Third thief would go and rob all the houses and come back. Fair enough? Every thief is of the same kind. Now suppose everyone's motive is same. Everyone is of the same thief. Okay, like all the houses are same. Houses targets are same. Thieves are same, but they are all acting individually. Now, if they are on the same team and they want to rob all the houses and they start robbing all the houses at once, then just see how by just the time frame of just one thief, every thief can start working. Every thief can start working and every thief can just rob the house. Okay. Okay. শুভাশিস মুলা ওয়েস্ট বেঙ্গলে কোথায় থাকো দাদা? আই তো আমি নিউ গড়িয়া কবি সুভাষে থাকি। Okay, but as of now I don't think it is a good time to meet, okay, because tomorrow is my semester exam of cyber security. Okay, and day after tomorrow is a holiday or a study break, and then again on 9th I have my semester examination. Okay, fair enough. So now let us move back to the coding part of this. Okay. Okay. So we saw that array. Just go back to the video. Okay. So we saw that array. Now we would be seeing the same array once again. Okay. So vector int dx of size 4 is equal to 1 minus 1 0 comma 0. Okay. Now int dy of size 4 is equals to the same way 0 comma 0 comma 1 comma minus 1. Now where from these values I have written them in the. I'm lazy enough, so won't be writing grid again and again. So just stay. Okay. So now we need to go down. When we go down, we would first have the, you remember that if it is outside the boundary, we need to remember that it is inside the boundary or not. So we would code for outside boundary also. So bull is valid, like it just needs to tell us true or false. Now it would take two parameters, the coordinates we are trying to go, x and y, and then the dimension. Okay. It is basically like this. Suppose my son is trying to go to a city. Okay. And uh, I have a person who would tell that if my child is within the city or not, if my son is within the city or not. So how would that person know? That person would take the country of country, like the city where I live, and he would take the name of the place where he wants to go. Then he would see that if it is within the boundary or not. In the same manner, this is the place that I want to visit. This is the whole arena size. Now it would just see if it is within the arena or not. So it would see, like, if x is greater than equal to 0, okay, or if x is less than 0, okay, like we can handle both the condition, all the true values or all the false values. Okay, so if x is less than 0, so if x is less than 0, or y is less than 0, or okay, or x is greater than equal to the value n, or y is greater than equal to the value n. If this is the scenario, okay, then we would say return false at either of this condition. If this is not the scenario, return true in all other conditions. You can write true or zero, but zero and ones act the same. Okay. Now the dimension of n and m is not given. So we would first find the dimension int n is equals to a dot size, int m is equals to a of 0 dot size itself. Okay. Now we need a queue of pair int comma int, and then we would have it as q. Then we would need the answer. Okay, like we need to return this one. So I would just copy the same thing. Okay, vector of int, and then answer of size n, and then vector int of size m, and then we would initially have the maximum value, like we would have, like, suppose the array is 3 into 3, so we would just have 100, the maximum one. Suppose we want to find the smallest element in the array. How do we find out? We assign it with a very large value, na? In the same manner, if we want to find the smallest distance or the closest distance, we would assign it with a very large value, which can never be the answer. Okay, fair enough. Am I clear till this point? I hope. Okay. So now we would traverse on the matrix. So for int I is equals to 0, I is less than n, and I plus plus. Now what we would do is for int j is equals to 0, j is less than m, and j plus plus. Okay. So now we would ask that if a of I of j is equals to the value 1, then the answer to 1 is 0 only. Answer of I and j is equals to the value 0. Now we would push all the ones. Okay, like from ones, we can go and find all the zeros. Okay, Either way is fine. You can push all the zeros also, you can push all the ones also. Either way is fine. I am just contradicting the explanation, okay, so that you would know both the dimension, that both of them is not wrong. Okay, like many people ask me, sir, is the solution right or not? This won't happen. Okay, that is why this is done, so that I contradict my own. Like there are many ways to solve a particular problem, there are many dimensions to see a particular problem. Okay. Okay, while q dot empty. Now we would have the x and y. So in q dot front dot first. Okay, this one is this element. Okay, this element, where is this? This element x. And then we would have int y is equals to q dot front dot second. We would have that. Next, we would remove the element from that. Same way as we wrote. Okay. And then we would have, if the particular, like we would have the new value of it, like we would have an array which would traverse over these all corresponding values to allow it to move on all the four direction. Okay, so now after q dot popping, after we have the x and y, we would now have an for loop to traverse the four location. Okay, so now what we would say, int nx is equals to x plus dx of I. Okay, int ny is equals to y plus dy of I. Right? Now, suppose we have got a new location, but we need to check if it is within the boundary or not. Okay, and it is improving the result or not. So if it is within the boundary, that means if it is valid. Okay, how it is valid? Nx comma ny comma n comma m. Okay, the destination we want to go and the perimeter. Okay, then we would move forward and we would say answer of nx and answer of ny if it is greater than answer of x and answer of y plus 1. Like this is something like this. Let me just explain you this. Suppose this is, so we are moving to this. So we would say distance to reach here plus 1 is the distance to reach here. Okay. So in the same manner, we would say here also. Okay, now we would say answer of nx comma ny is equals to answer. Okay, if it is answer of nx and y is equals to answer of x and answer of y plus 1, like we would improve the result. If we are able to improve the result, we would push it to the queue, push of nx comma ny, and we would enclose this in a bracket. Like we can use make pair also, and we can enclose them in the brackets also. Either way is fine. Okay, so then we would return the answer variable. Now I would see that I don't make any mistakes. Oh, okay, nearest vector line number 41, line number 41. I forgot this. Let's pray that there is not any small cell error. Okay, 001100111100. Okay, it seems like I have done the correct one. Let me see. Okay, now we are good to go. So we have a lot to type. Okay, so I didn't knew that this one would solve the purpose. Okay. Okay, so let me know if you have any errors or not. Okay, like if you have any issues or not. So I would quickly remove this and then share the tab of this, and let me know if you have any issues to this. Okay, so quickly let me know if you have anything to tell me. Like if you have anything to ask, quickly just ask me. Which line number? Just mention the line number. I would be waiting for the next 30 seconds. Make it a little bit quick. बेसिकली मल्टीपल पॉइंट्स चल रही होगी बीएफएस के लिए, इसलिए मल्टी सोर्स बीएफएस. No, he is asking how the multi source BFS is reducing the time complexity. Okay. Okay. Thank you, Shubhashish. What about Rishit Shayantani Goa? And then Shubham Pawar. Okay, I see many Bengali. So can't we do this using DFS? No, because DFS does not guarantee that the path that he would give is the shortest path. Okay, so if we talk about shortest path, DFS does not come into picture. जब भी shortest path बोला जाए, if the graph is unweighted, we should think of BFS. If the graph is positively weighted, if the graph is positively weighted, then we should think of Dijkstra. If the graph has no negative, like it has then Bellman Ford, then we need to move forward with flawed Warshall. Then 0 1 BFS is there. Many things. Okay, so by the way, if you want to learn about BFS, DFS, and multi-source BFS, there is a video of mine in 30 days of programming, and that was my third or fifth day. I explained it from scratch, like graph from scratch. Line number 38. Okay, let me see line number 38. What is line number 38? Line number 38 is that suppose we have the new location. So this here we are finding out the new location. After we are finding out the new location, we would first see if the new location is within the perimeter or not. First, if it is within the perimeter, then we would move forward. That's why a AND condition. Then we would see that we have first assigned it. So how do we do? Like suppose whenever we want to find the smallest element in an array, we would compare that if the current element is less than the previous element, we say this. In the same manner, we would say here also, like we have initialized with int max. So we would say if the current distance is less than that previous answer, then assign it. In the same manner, if the current distance is more than if the current distance is more than the previous distance, assign it and then push it. Okay, any more further queries you have for boundary check? Yeah, absolutely. Half of it is boundary check, half of it is finding the minimum value. Done. Okay, so I would wait for the next 30 seconds and then I would turn off the session if I don't receive any further queries. So if you're watching this on the recorded version, or if you were here till this point of the solution, consider liking the video and commenting on the video so that the reach of this video could be increased. Thanks a lot. Have a nice day. Okay, fair enough. And for those people who are having their semesters at the moment, all the best to them and to me too. Okay.